Uh, yes, hello everybody. Here, myself, Dr. Veeranna Kottigi, we are discussing about data structures using C, and in that we are discussing about stack data structures. So, in the previous session, we saw that how the push operation will takes place in the stack and how the elements will be pushed into the stack. Okay, so and also how once we push the element, how to display the elements that are there in the stack. So those are things we have discussed in the previous session. So in this session we will discuss about the pop operation of the stack. So pop operation means removing an element from the stack, or it is deleting element from the top of the stack. That operation is called as a pop operation. So the definition goes like this. A pop operation in a stack removes the top element from the stack. Because basically it will remove top element from the stack, because the stack follows the operation called or method called as LIFO, that is last in first out. So here the element that has been inserted or pushed into the stack at last will be popped first. So that is what this pop operation will do. So once it removes that operation, the next element again which will be at the top, then again it will remove if you again execute the pop operation. So it will continue like this till till we stop the pop operation. So the algorithm for this pop operation is like this. The name of the algorithm is pop, and for this pop operation we give two parameters. One is stack and another one is top. So you can see here the algorithm, this pop is the name of the algorithm, and stack and top are parameters that we are going to supply to this pop operation. So it will take these two as input, and then it will start deleting the element or popping elements from the stack. So now we will see the what is the first step. The first step is the pop operation will check whether top is equals to -1. So what it indicates, the top equals to -1 indicates there are no elements in the stack. So that is why the pop operation, before popping an element from the stack, first it will check whether, or first it has to check whether any elements are there in the stack. So only if there are elements in the stacks, then it will go for popping. Otherwise it will print stack underflow. So that is why if top is equals to -1, and if it is yes, that means if top is equals to -1, then it prints stack underflow. That means there are no elements in the stack and it will exit. So it will stop executing the pop operation. If this top is not equals to -1, in that case it will go to the step number 2. So what it will do here is it will set stack of top as equals to what? The item. That means the top of the stack, whatever that element is, that element will be taken as what here? The item. So that item is the one the pop operation is going to pop from the stack. So right now the item contains the element which is at the top of the stack. Then it will go to step number 3, and then it will decrement this top value by 1. So if it decrements top value by 1 means the element which is at the top has been deleted. That is the meaning of this decrement top by 1. So how it will decrement? It will decrement top -1. So it will decrement by value 1, and the new value that it is going to get after decrementing top by 1, that will be taken as the new top. So that means it will point to the new top. So once it decrements, then it will go to the step number 4, and here it will return the item, that is this item it will return. So this item is nothing but the element that has been popped from the stack, and then it will end. So like this it is going to pop an element from the stack, and that element is the one which is at the top of the stack, or which has been added recently into the stack. So this is how the algorithm will be written for pop operation of the stack. And now we will see a little explanation about this. So as I said already, top equals to -1 is stack is empty, or the stack is in underflow condition. That means there are no elements in the stack. So stack of top indicates it will access the top element in the stack, or which is at the top position in the stack. That element it is going to access. Then top equals to top -1 means what? It will remove the element by updating this pointer. That means first it will make a decrement the top by 1, and it will be, that means if the top value is 4, then top value is 4 means 4 minus 1, that is equals to 3. So that 3 will be assigned to the top. So now top equals to 3 means the element which is at the position 4 has been removed. That is the meaning. Then the removed element will be stored in the variable called the item. So this is the simple explanation of this pop operation of the stack. And now we will see the C program, how to write a C program to pop an element from the stack. We'll see that. So first we have to write the hash include stdio dot h. So we know what is stdio dot h, that means standard input output. So it is used to input elements and also to output elements. So that is why we will write this hash include stdio dot h. Next, define max 5. So that means here why we will take the constant value max 5 is basically because I want the stack size to be of maximum size 5. So that is why I will take maximum value as 5. And now you see we will use this max here. So int stack of max, that means int stack of what? Max value is what? 5. So it will become stack of 5. So that means stack size is what here? 5. So we can only store maximum of 5 elements into the stack. So that is the meaning of this. So initially top will be equals to -1. So that means the stack does not contains any values. That is the meaning of stack is equals top is equals to -1. So now we will write, we already saw how to push an element into the stack and how to display those elements that are pushed into the stack. We saw it in the previous session. So now we will see how to pop those elements that are there already in the stack. So I will write a function called pop here. We will write like this: int pop. So, so then I will write this floor bracket, and then I will check the condition of the stack, because before removing any elements we have to make sure that there are elements in the stack. Okay, so that is why we will check whether there are elements are there in the stack. So if top is equals to -1, so that means here stack is pointing to -1 in the, it means that there are no elements in the stack. So in that case it will print stack underflow. So stack underflow means stack is empty. Then it will return -1. So this is the if condition, if else condition. So we will check first whether there are before popping the element from the stack. Before we have to check whether stack contain any element, and if it is underflow then it will return -1 and it will stop. Otherwise, it will come to the else part and execute these three statements here. Then what are these statements in the else part? It will first the top stack int item equals to stack of top. That means stack top element, whatever element that is at the top of the stack, that item will be assigned to what now? Item. So the item contains the top element of the stack. Then once we assign the top element to the item, then we will decrement the top by 1. So since maximum size is 5 here, let us assume that it is this element that we have assigned here to the item is at the 5th position only. That means at that time top was pointing to what here? 4, because it will index since it has been implemented using array, the index will start from 0 and it will end at 4. So the top value is what? Earlier 4. That 4 minus 1 we will do it here. So 4 minus 1 is what? 4 minus 1 is 3. So the new top value is what? 3. That means since top p value is 3 means what? The element which has at 4 has been deleted. That is the meaning. Otherwise top would have pointed to 4 only. So since we have decremented it and top equals to becomes 3, that means top is equals to what now? Top is equals to 3. That means the element has been popped from the stack. Then it will go to this that is line, and here what is written here? Return item. A return item means it will return the element or the item that is that was at the top of the stack. So this is how the pop operation will happen in the stack. And now we will see this push function for testing this. Actually, we have already seen this, but before what I say, popping an element from the stack, first we will try to push elements into the stack and then we will go for popping. So first will here for the testing case, we will write this push operations also here. So we know how to write push operation, that is void push int value, and if top is equals to maximum -1 means it is the top is pointing at the last location. Top is pointing at the last location means the stack is full. So that is why it will print stack overflow. And then it will come to the else part. Okay. Then it will come to the else part. That means if this if condition is not top equals to -1, that means still there are some positions left in the stack to push elements. So that is why it will come here and increment the top to the next value. So if it is 3, then it will become 4. That is top plus plus is equals to top plus 1. So at that new top, I will push the value. Here, see here we have given this as parameter to this push function. So the same value will be stored at the stack of top. That means it will be right now this value is at the top of the stack. Now we have pushed the element. Now we will display it. We also saw how to display the element. If stack is equals to -1, it will print stack is empty. Otherwise, it will go for else part and it will print stack elements from top to the bottom. So, so that is what it is written here. And now we'll go for this int main and display. So this we know already. So this is just for pushing these elements into the stack. So here the first element pushed is 10, the second element pushed is 20, and the third element pushed is what, 30. So as per the stack rule, the last element pushed is 30. So the top element in the stack is what here, 30. So then it will display those elements, and then I will go for pop operation. So I will write int deleted equals to pop. So once the control comes to this line, the control goes to the pop operation. So where is the pop operation? We know that. So the control goes there and it will check whether the stack contains any elements or not. But as we have already pushed these three elements, the top will not be equals to -1, so it will be pointing to 2 here because there are three elements. So it will be pointed, top will be pointing at the index 2, and at that index the element stored is what here, 30. So then it will go to the else part of the pop operation and then it will pop that element, and that is will be taken as deleted here. So if deleted is not equals to -1, okay, that means what, it will print a popped element %d/n deleted. So it will print the deleted element, okay, because the element that has been popped will be assigned to what, deleted. So deleted contains the popped element, so the popped element is what, this deleted value. Then it will display the stack. When it displays the stack, the stack contains the elements what, 20 and 10, where 20 will be at the top and 10 will be at the bottom. So this is how then it will return 0. So this is how the pop operation will execute in the this we can see here, stack element pushed 10, 20 and 30. 30 is at the top. So when I execute or when the pop operation execute, 30 will be removed, and then again display will execute. So it will display elements 20 and 10. So if we run again the pop operation, then 20 will be removed and 10 will be displayed. So like this it will continue. So this is about pop operation. Now we will see some of the application of this pop operation. The pop operation will be used in many different real world applications. For example, expression evaluation. That means it will be used in evaluating postfix expression and prefix expressions, because here in expression evaluation we are going to remove operands and operators during computation of this expression evaluation. So there this operation will be used. And then there is another application, that is undo operation. So for example, in text editors where we use tags, it will be used to remove the latest action that has been taken place, whether it may be adding, writing any number or any word or any sentence. So whatever the recent element is, If we want to undo that recent operation, then this pop operation will be used. Then it is also used in function calls a recursion, where the same operation will be called again and again, so that it will remove the element that has been executed or pushed into the stack. Or in recursion, recursion is nothing but the calling the same function again and again.